Good day from OG Benchmarks. Over the past year, I learned that some desktop motherboards can accept a socketable mobile CPU. Even better, a few of these motherboards have a thin mini-ITX form factor. So let's talk about one of these boards, a motherboard with a PGA 988 socket. PGA 988. This is an old socket for socketable mobile CPUs from the Westmere, Sandy Bridge, and Ivy Bridge generations of Intel. Now, many of the mobile CPUs from those generations, as well as more recent generations, were embedded, but a decent number were socketed. These are PGA CPUs like the AMD chips, but not the new Ryzen 7000 chips. The CPUs have pins on the bottom. Not all PGA 988 sockets are the same. The Westmere CPUs fit 988A, called socket G1. The Sandy and Ivy Bridge CPUs fit 988B, socket G2. There are boards with a PGA 989 socket that can accept all three generations. Most of these motherboards are for laptop PCs, but a handful are designed for desktops. So this is really interesting. These boards represent the only way to put a Westmere CPU into a thin mini-ITX build. It's kind of a niche application, but it kind of interests me in the thin ITX space. Where can you find these motherboards? On AliExpress, of course. Well, I bought one of these boards, and here it is. It has a low profile, just like a thin mini-ITX board should. It has an HM55 chipset. That's the mobile version of the H55 chipset used by Nehalem and Westmere CPUs. Just about all of these PGA 988 or 989 boards have only one RAM slot. These boards do have mSATA slots. By the way, I love these mSATA slots, which were the predecessor of M.2 drives. Just like an M.2 drive, you can get storage without having to manage SATA power or data cables. The board has a 12-volt barrel jack for power input. None of these boards include I/O shields. I managed to contact one seller on Alibaba, not AliExpress, who was willing to include an I/O shield. The price was steep at $70. That's a total ripoff. You can get these boards for less on AliExpress, but I did want an I/O shield. Full disclosure, when I bought this motherboard, I didn't fully know what I was doing, and I thought it had a chance of supporting not just Westmere, but also Sandy Bridge and Ivy Bridge. Let's talk about this a bit more. Here is some information from the Alibaba listing. Note that the socket says PGA 988/989. 989 is what I wanted, and the socket that supports all three generations of CPUs. The catch, which I now understand, is the chipset. HM55 is Westmere only. In the end, the motherboard arrived so late that I submitted a refund request. It took forever, figuratively. Even worse, it did not include the I/O shield. And of course, it was Westmere only, PGA 988A, socket G. Regardless, it is a thin mini-ITX board for Westmere CPUs, and that was my number one interest in this whole project. After being a little bit disappointed with the motherboard, I was very excited to find this PC case on AliExpress. This is the QX02 case. It has a built-in I/O shield. Furthermore, the rear I/O ports on the board I bought, and all these PGA 988 boards for that matter, line up perfectly with the I/O shield on this case. It's almost like this specific case was made for these PGA 988 boards circulating on AliExpress and Alibaba. Well, I jumped on this case in a heartbeat because it was going to cover up my I/O shield failure on the motherboard. In the end, this case brought more disappointment. When the case arrived, it didn't have a built-in I/O shield. At this point, I was a bit irritated. Work picked up, and my plans for the PGA 988 build went on the back burner. This project was shelved for a while. What revived my interest was my son getting a 3D printer for his birthday this year. With a 3D printer on hand, I could print my own I/O shield. To the left is an image of the back of the case with its supposed I/O shield. I printed out a different, low-profile I/O shield shown on top, and then changed the model through iterations to get something that matches the back of the case. The bottom print is not the final print, but it's getting pretty darn close to matching the picture of the case on the left. All the parts are now in place. Here is the part list. We've talked about the motherboard and case. The CPU will be a Celeron P4500. That is the rock bottom Westmere mobile CPU that fits the PGA 988 socket. The power supply is a 12-volt adapter with a 5.5 by 2.5 millimeter barrel jack to fit the motherboard. The cooler is a low-profile Silverstone NT07. The GPU is the integrated GPU on the CPU, since this case won't fit a dedicated GPU. I used one stick of DDR3 1066 RAM, that's SODIMM RAM. Finally, I used a 128 gigabyte mSATA drive. I needed something with at least decent size because I wanted to install Windows for benchmarking. Here is the build in the case without the side panel. You can see the cooler, the RAM, and the mSATA drive. Again, no cables for the storage drive, very convenient. I don't have anything for scale, but this is a tiny case. It's about 190 by 190 millimeters square. That's about 8 inches square. The height is 45 millimeters. That is a case volume of about 1.6 liters, which is a very, very small case. Here is the final build with a front view and rear view. This case cost about $30 on AliExpress. It's a nice looking case from the front. The rear of the case also looks nice with the I/O shield in a matching black. The black I/O shield looks way better than a silver metal shield in my opinion, although nobody's going to see it in the back. The system booted just fine. I did install Specky, a low-rent hardware monitor. Note that Specky information indicates that this motherboard is not intended for direct sale to customers. Instead, this is a board for OEMs who are making mini PCs with their own branding. Note that the BIOS date is early 2020. This is a new product and not old stock that's been sitting in a warehouse since 2012. Now let's get into benchmarking. Since I did not get a PGA 989 socket that could handle Westmere, Sandy Bridge, and Ivy Bridge CPUs, I decided to try 3 different Westmere CPUs, a Celeron, an i3, and an i5. I benchmarked these CPUs with Cinebench R23 and Heaven. I'm not showing all the information from the benchmarking runs, only the interesting results. Let's start with the Celeron, the P4500. The Celeron with its 35 watt TDP has a base frequency of 1.86 gigahertz, no turbo, and the integrated GPU clocks up to 0.67 gigahertz. Here are the results. During the Cinebench run, the CPU did hit its target clock speed, and it did so without needing its full 35 watts. This is pretty common in the lower end Intel CPUs. The non-turbo CPUs often don't need their full TDP to hit their promised clock speed. The Heaven benchmark 1080p gave 3 FPS on low and 1.2 FPS on medium. There are no surprises in these numbers. These results represent the baseline for the Westmere CPUs. Up next is the i3 3500M. It has higher clocks on the CPU, still no turbo boost, and the same GPU clock speed as the Celeron. The i3 hit its target clock speed, again with only 25 watts. Heaven scores were the same as the Celeron, which is also expected since the GPU clock speeds are the same in both the Celeron and i3. Okay, how about the i5? The i5 has higher speeds on both the CPU and GPU. The i5 can also turbo even higher on the CPU. So what I expected to see with the i5 was that, number one, the CPU clocks will be higher than 2.4 gigahertz. Two, the power will be higher, likely even higher than the 35 watts with the turbo. And three, the FPS on Heaven should be higher. Here are the results. I can't explain these numbers. I checked the BIOS settings multiple times to make sure turbo was enabled. Why is there no turbo on the i5? Why are all the power levels read in hardware monitor identical? Why are the Heaven FPS values identical even when the GPUs have different clock speeds? My hunch is that the motherboard is not fully featured, but I really don't know. If you have any ideas, please let me know in the comments. I hate to admit it, but when I'm involved in benchmarking, user error is always a real possibility. But I'm inclined to blame this to be filled in by OEM, no-name motherboard. What are my takeaways from this build? First and foremost, this is a thin mini-ITX build with a mobile Westmere CPU. That's pretty cool, and for this reason alone, this build is a success. Beyond that, I'm running short on positives. I bought the wrong socket and chipset because I didn't fully understand what I was doing. I overpaid to get a board with an I/O shield, and then the I/O shield wasn't included. I bought a case because it had a built-in I/O shield, and then it didn't have one. Performance during benchmarking was not as expected. Of course, when I say not as expected, I mean lower than expected. I think this is a motherboard quality issue. There is one additional positive, which is actually a pretty good one. Printing the I/O shield worked great and looked even better than a metal shield. Well, that's it for this video. It was a bit of a bumpy ride. Thank you for watching to the end. Please subscribe, leave a like, or make a comment. Take care.